Hello YouTube, how are you doing? And this particular video is on Tekla Structural Designer. I'm back with another video on Tekla Structural Designer, and this video I'm going to uploading in YouTube as well as my Udemy course on Tekla Structural Designer. So if you're wondering if you need a particular course where you have detailed materials, all the CAD files, all the detailed instructions, and this chat guidance for Tekla Structural Designer, building design using IS code, you can consider registering in my course on Udemy. The link I've given in the description. And as you can see, currently on this date, the 24th Feb 2023, 487 students have already been registered in this particular course. And I'll update it now. Last, you have 11 ratings, and you'll have this. Currently the offer is also going on for this, so you can, if you're interested and really serious about learning this software, if you need assistance, you can consider registering in this course. Okay, so this is it, and we are back with our basic thing, that is building design in Tekla Structural Designer here, and this is our plan here. Okay, so this is our plan, and this is basically, this one is a bedroom, this one is a bedroom, this one is a drawing room, this one is another bedroom, and this one is a staircase. Basically very simple plan. This is an actual project, and this we have to design it for G+2. So I've also designed this building in style and RCC, and and now I'm going to design this building in Tekla Structural Designer and see what are the results. So as we know, I've done the center line in many particular videos. So in centerline, you need to keep layers as minimum as possible, and you can keep the artificial grids and the centerline in a separate layer. But since I have made the file in STAD Pro, so you can see centerline for STAD. This is DXF file, I think. Yeah, DXF file. So in STAD, only the centerline is required, not done in the architectural grid. But here it is not an issue, because all the places where we have an intersection, we have a column. So it's like this is a very simple structure. So no need to import the architectural grids also. So we have the center line here and the XF format, and the unit of this is in mm. Okay, another one in meter also we have, but this one we'll use in mm. Okay, so just I'll just close this because it's a DXF file, and I'm just going to open the Tekla Structural Designer here, and just want to go with a new project here. So if you have the student ID, the 1-year license is available for this Tekla Structural Designer. Okay, so first of all, go to model and go to construction levels here, and here we'll just insert below first. So plinth height plus foundation height is 1.9 meter. So we'll just go here 1.9. Some people make mistake, only they enter the foundation height, but you have to add the plinth height as well. That is from the GL to the PL. You already have to add this as well. Here, in this case, the foundation height is 1.5 meter and the plinth height is 0.4. So this you have to do, and let's insert above here, and this will be SSL, and the spacing will be 3 meters actually. Okay, so this will be the spacing, and the slab thickness will do here 125 mm, and slab thickness is in mm, and SSL means structural slab level. So this is G+2 building, so insert above 1 and 2. So G+2 has been sorted here, and then just click on OK. Make sure you're on the plinth level. If you want to know, and go to levels here, these are all levels. Double click on this, and this here we on a plinth level. So you're on the plinth level. We're just going to import the file, import the DXF, and here we're just going to go to the folder where you have the file center in meter, and this is the center line in mm. So we'll open the file in mm here, and already told you the layers, keep the layers minimum as possible here, and units is mm, and this is architectural grade here, and click on next, and I'll import this in I can import this in everywhere, but okay, let's see by layer, and let me just import this grid everywhere and click on finish. Okay, so once this is done, the color here, as you can see, the color is in white. So if you want to change this, I just go to just make this black. Okay, so now it is fine. The center line is in black, and now just save this file, because when the file becomes large, sometimes it may create problems. So always G+2 building, just save this file and then click on save. Now the first thing which I want to do is the column positioning. Just click on column here, and here I want to save the properties first. Before that, make sure M20 concrete is used, and the size is what to use is 300 first, and let me check 300 is passing. Otherwise, we'll go for a larger size, rectangular, adding, and automatic alignment. I'll just turn it off for now. Okay, and FE500, we go FE500 for now, but FE550 is also available, but in this version of software it is not available. You can define it. So let's go with FE500 for now. Okay, nominal cover 450 mm. So in all places we have this column, so I'll just do this. Otherwise, you can save this property also if you're planning to apply different columns here. So you can see in the structure 3D, and right click your mouse and rotate this. So you have the columns which are ready. So now when the column ready, make sure you go for the plain beam. All the beams are primary beams here, so no need to worry here. Go for the beam. And here in this particular thing, just go to 50 into 350 for the beams. And then I'll just drag and complete all the beams here. And there we go. We have the beams. So now go to model, go to construction levels, and then we'll just copy this one from the base and then click on OK. And then we'll go to construction levels once again, and then make this as unique, because we need to insert some unique properties to this. So for that, just go to this particular level, and which is the structure 1. Double click on that. You'll go to structure 1 and just click on slab on beams, and you can add the slabs here. Already you've defined 125 mm slabs, and one-way slabs they don't design, so no need to check one-way slabs also. Okay, so all the slabs are given here, and this is a one-way slab, but I have not given because I have not even given the slab here. Okay, so all the others are two-way slabs. So this is done, and so this is the building. So now you can copy this. For copying this, just go to construction levels and make this as 1, and also this as 1, and click on OK. Once this is done, go to construction levels and make them both as unique. Now you might notice that you have the staircase portion where I have not inserted any slab. So all these things need to go up. So go to construction levels and we need to insert above. So by default, the height is 2.8 meter for the headroom, maximum height for the headroom where you have the staircase ending. So spacing is 2.8 meter, and click on OK. Now, once you have defined the headroom height, just click on the 4 columns, use Control in your keyboard to just select multiple columns, and then the top level, make them as structure 4. Columns will automatically go up, and you can the easiest way is to go to structure 4 and then take your beams, and already you have the beams defined, and just add the beams, and slab also same case you do, add the slab. So if you just now go to structure 3D and look, escape, you can escape and look, you have the entire structure. But wait, you need to assign the fixed support as well. So by default, we have a support which is assigned. Just click and select all the supports here. Make sure all the supports are selected. So press Control, sorry. Best way is, I think, which you can select support. I just go to any particular view and then select, it will be better. So right click and see, now all the supports are selected. Now make all this free as fixed. So it will be fully fixed support, which is generally done for and assumed for monolithic construction. Okay, so fixed supports are given. This denote the connection between the footing and the columns. Okay, so these are given here. Now once this is done, now just go for the loading. So go to load and just select the load from down below, dead load. Now we'll go and assign the dead load in the plinth level first. So for this is actually 5-inch wall in this thing, so the loading is less. I've already told in many videos how to calculate the dead load for the walls. So loading is coming as 7 kilonewton per meter. So what you'll do, dead load already selected here, and then go to full UDL and then go to 7. No need to apply directions or negatives here as you do in StatFlow. Okay, So just select all the beams one by one. So there is no shortcut in this case, like you can drag and select in stat. So there is no shortcut for applying the loads in this case. So that is a thing which you can work. If I find a shortcut, I'll let you know. Then in structure one also, same thing, just go to the load here, dead load. And if you want just to remove the slab in the scene content, this slab item just remove. It will be easier for you if you just remove the slab items. Okay, this cannot be removed right now. Now it can be removed. After click on escape, it can be removed. Okay, I selected, that's why it's not allowing me to remove. Now it can be removed. It will be better and easier for you. Now just go to full UDL and just take this 7 and apply it one by one. As I told you, there is no shortcut currently available to apply. Select all the beams and then apply. But if there is, then you can also let me know if I don't know. Okay, so this is done, and after this is done, I'll just click on escape and scene content. I'll just click on the slab item. So I want to add the floor finish load, which is 0.5 in this case for the tiles, marbles, and all. So for the floor finish load, I'll go click on the level load and same 0.5 I want to add here as a level load in the dead load part. Okay. So dead load has been added, and I wish to copy this load to the next load. So I'll add the live load here as well, and I'll go import load and level load of 2 for the residential building, and click on add. And go to structure 3D, and very interesting, the dead load is on. So you see the dead load, import load is on. You see the import load here. Okay. So in this floor I can copy, in this floor I cannot copy. So these two floors are similar. So what I'll do is we'll go to model and go to construction levels, and in the next floor, this source of 2 will just do this as 1, and then click on OK. Right. So this, as you can see, this is copied exactly. Now go to construction and make them back as unique, because we don't want any interference. Okay. Now it is back as unique. All the things we needed to and wanted to copy, that is in place of the dead load and the live load, these are done. Okay. And now what we want to do is we want to apply the loads in the parapet wall part. So for the parapet wall part, go to the parapet wall floor, that is the structure 3 in this case. And now what we want to do is we want to go to this dead load, and we are going to go to load and full UDL for the parapet wall. But first of all, let's apply for the staircase portion. 7, 1, 2, 3, and 4. And then for the parapet wall, we're going to apply 3.5, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then floor finish load, if you want to add, can but you can also ignore it because there is no floor finish here. There are no floors of this. Live load also same case, you can ignore in this case, but I'll add the live load here. Okay, so import load and just go to level load and give a live load of 2, just in case we have been live load as well. So this is the dead load. You can see the magnitude difference between these two applied load, parapet wall load and the other load. Okay, so here there are no difference between internal and external walls. All walls are 125 mm thickness, so that's why there is the same loading. Okay, so I hope these confusions are clear. Just save this file, and it's a good practice actually to go to this home. Okay, where is the option? Okay, go to model option and click on validate. So you can check again and again whether everything is right. So for my model, everything is right, everything will come green. So everything is right till now, and it's a good practice to save the model again and again also, and in different thing also you can do it. So this is done. Now let's apply, go to your model only, and let's apply the wind panels. Okay, so the building height, as you can see, is less than 10 meters. Basically the wind load application is not required, but just for showing you, I'm just doing this. I'll delete it later and see the results, or else you can do one thing. Let's design it by earthquake load fully, and then we'll apply the wind load and see there is any difference. Okay, so let's go. We'll go to loading and we'll go to this seismic load and we'll apply the seismic wizard, and then we have the code spectra. Obviously, we're going to go by the code spectra, ignore seismic below the plinth level, right? And these things will take automatically. Seismic zone, we have zone 5 here in Tripura, importance factor 1 for residential and 1.2 for apartments also. And zone factor all they will take automatically next, and we'll all use here, model response spectrum analysis, and then click on next, and then structure type is obviously RC, moment resisting frames, uh, without any moment resisting, without any masonry infills, and then click on next, and then you have type your moment train system and special moment resisting frame system. So wondering you what is the difference between OMRF and SMRF. In SMRF, ductile detailing is considered. Okay, so just first of all select all this and then take it here next, and you can add this drip check, or you can skip this also, it doesn't make any difference here, and then click on the operating next, and finish. And then we'll go to load and load combination, and then we'll click on let's click on generate the load combination, and you can ignore this load combination also. The working, if you're wondering what is this, in Indian code there are two types of load combination: limit state, which are currently using. Earlier you used to use working stress method, so that is this thing. To use working stress, the sections will be heavier and it will be less economical but more safer, I guess. Okay, notion horizontal force we don't want to add. We will just click on finish and click on OK. And you have added the load, so you have the load combination, and we have the go to design and simply click on design all static. It's the simplest way to design all the structure. You can also use the RSA, but in RSA the structure is a little bit heavier. We have used the RSA for seismic, mind you. Seismic load we have used the RSA, and the dead load and the live load we are using the static method. Okay. So yeah, we have a warning here for the beams here. So let's see. Right click and then we'll go to check member static. What is the warning here? So it is passing in everything. So let's see what is the warning. So longitudinal bars and bar limit, it is passing, but I think its bar limit is good, because in longitudinal bars, if it is this 2 bars of 20 mm, it is okay. Okay, 3 bars of 20 mm and 3 bars of 60 mm, okay. And for axial force, it is also showing some errors, and so yeah, this is showing some errors. So if we, let's see if we can resolve this errors here, warnings here, all else you can proceed to go for this design as well. So this plinth beams, for the plinth beams, I'm just making sure I give a different size here. 350, I think it's enough, and I'll just increase this size to 300, and let's check here what is the difference here. And right click I'll do, and I'll do design selected static, and it is failing now. Okay, right click, and but the steps are complete. I'll just let's just see here. 316 passing, and okay, yeah, failing only in the stirrups. Stirrup limit checks, it is failing. So I'll go to model. So I'll go to design and design settings, and and we have the stirrup settings. Minimum spacing is 100 mm, maximum spacing is, let's do maximum spacing also 150, and spacing maximum spacing also 150, and save, and okay. And then let's just design a member here. So still it is failing. This if you design by the Indian code, there's some errors, this limit checks, some error comes often. So as you can see, there are some glitches actually. It is saying the maximum allowed it should be 222, but I have done it 100 mm or 150 mm. So if this is less than 222, there is not, there shouldn't be any error, but it's still showing error. So it is, we are good here in place of the in case of stirrups, as far as the longitudinal bars are, okay. So if you just guessing now how there is the glitch, how I'm supposed to know, you can go to review and you can just check the ratio. So you can check if there is anything more than one, okay, that then the members are failing. So, and if there is anything close to green, then members are extremely uneconomical, that is 0.9. So blue also it's okay. So let's check for the suppose let's check for the columns here. The columns are okay, and design member static, and this 40 16 is fairly fine. Columns 4 bars of 16 are coming here in this. Let's check this one. Right click design member static. It is also 4 bar 16. So all the columns are of 4 bar 16. In some columns, these two columns are failing. So let's check this design member static. This is also passing actually. This is a glitch. Four bars of 16, all columns are passing. And let's take a general beam here where we're supposed to have more loading. Okay, let's check this beam. Right click and design beam here. Now 2 bars of 20 and 2 bars of 16. Next 2 bars of 20 and 2 bars of 16. 2 bars of 20 and 3 bars of 16. So beam results is also very good. And longitudinal bars, if they're failing, then we have to increase the size. I think 300 mm, which we need to do it. But remaining thing, also longitudinal bars is not failing. Only in bar limit 6 is failing. But I think bar limit this is okay. For 250 mm, we can use 2 bars of 20 mm. It will not fail. But this is only a glitch. So the design is okay and no problem with the design. And here one section that is showing is failing. Let's check this also. Okay, here this particular beam we need to change because this is failing in a particular analysis. So this particular beam we need to change this depth. Let's change this depth to, let's go 400, 300 into 400. Now right click and then design member. Now it is passing, right? It's passing in the stirrup limit as well. So 300 to 400, if you give, it will pass. All the beams will pass. Even the stirrup checks will also pass. So that's what the software is trying to tell us. Okay, so we have done this till now. Let's not give WinLoad and load this further. I will show you WinLoad in a separate video. Let's complete the foundation. So go to foundations here, and we have the pad settings. Just let me just check the settings first for the foundations. General, isolated footing, we're going to design here. Reinforcement 10, maximum loose bar, let's go 16. Okay, and minimum clear spacing 100, maximum clear principal bar spacing, let's go 150, and this also let's go 150, and click on save, and okay. Okay, so pad base column here, just a soil test report. You can just insert the SBC here. Let's do 120. Okay, and insert this, and then design pad bases. It will show a warning which is of development length. If you design by Indian code, this warning comes, but no need to worry about that. Okay, right click and check design member. You see everything is passing on, development link warning is there, so no need to worry about that. You can see the size of foundation details. Size of the footing is 2.5 meter into 2.5 meter. So 2.5 is the maximum size. If you just multiply it and 3.28, you can see it is around 8 feet, the maximum size of the footing. A little bit more than 8 feet, 2 inches. Okay, so and we have less number sizes as well, 1.6 as well. So 1.6 as well, the footing is there. So like this, you can have 5 feet, 6 feet footings also. These are there. So this is the design which is coming in the Tekla Structural Designer, and obviously we have various ways of exporting the drawings as well. So we'll cover this in a separate video, and also the WinLoad part also we'll cover. This video I don't want to make it too long, so keep learning and make sure you, if you have come this far, make sure you hit the subscribe button if you haven't, and also consider liking the video because it really helps this channel. Thank you. Bye bye.